Far beyond Earth, nearly 1.5 million kilometers from our planet, a silent observatory drifts in darkness near the gravitational balance point known as L2. Unlike telescopes built to capture dramatic explosions or glowing nebulae, this machine was designed for something far more ambitious. It was built to uncover the hidden structure of the universe itself. Not simply to observe galaxies, but to trace the invisible forces shaping them across cosmic time. This is the Euclid Space Telescope. And what it is beginning to reveal may transform how humanity understands reality. When people imagine the universe, they often picture scattered stars floating randomly through empty space. But the deeper science looks, the less random the cosmos appears. Galaxies are not isolated islands drifting aimlessly in darkness. They gather into clusters, stretch across colossal filaments, and surround enormous voids spanning hundreds of millions of light years. Together, these structures form something scientists call the cosmic web, a vast hidden framework woven across the observable universe. For decades, this web existed mostly as theory and simulation. Equations predicted it. Computer models suggested it. But now Euclid is beginning to map it directly with astonishing detail. Its first images stunned astronomers. Millions of galaxies appeared packed into enormous survey mosaics, each tiny point of light representing entire star systems spread across billions of years of cosmic history. These were not ordinary photographs. They were fragments of a gigantic three-dimensional map humanity has never possessed before. A map not just of visible matter, but of the invisible architecture guiding the evolution of everything we see. Because Euclid's true mission is not focused on stars alone. It is searching for dark matter. Dark matter remains one of the greatest mysteries in modern science. It cannot be seen directly. It emits no light, no radiation, no visible signal. Yet its gravity shapes galaxies, bends spacetime, and influences the motion of matter across the universe. Scientists believe most of the universe's mass may exist in this invisible form, meaning everything visible, stars, planets, nebulae, even entire galaxies, may represent only a small fraction of cosmic reality. Euclid detects this hidden presence through a phenomenon called gravitational lensing. As light travels across space, massive objects distort the fabric of spacetime itself. This bending subtly warps the appearance of distant galaxies. The distortions are tiny, almost imperceptible, but Euclid was built to measure them with extraordinary precision. By analyzing these patterns across billions of galaxies, scientists can trace where invisible matter exists, effectively mapping structures no human eye could ever see directly. And what those maps suggest is deeply unsettling. The universe appears threaded together by enormous invisible scaffolding. Vast rivers of dark matter stretch across cosmic distances, guiding galaxies into clusters and filaments like unseen currents shaping an ocean. The luminous universe begins to look almost secondary, a thin visible layer draped over something far larger and stranger beneath it. One of Euclid's most remarkable early observations focused on giant galaxy clusters filled with hidden detail. Researchers identified countless faint dwarf galaxies previously invisible to older surveys. Though tiny compared to massive galaxies like the Milky Way, these dwarf systems are incredibly important because they react strongly to surrounding dark matter. Their distribution acts almost like fingerprints left behind by invisible gravitational forces. And those fingerprints hint that the hidden structure of the cosmos may be even more complex than current models predicted. Elsewhere, Euclid examined regions astronomers thought they already understood. Familiar nebulae. Ancient star clusters. Nearby galaxies studied for decades. Yet even there, it uncovered hidden populations of stars, faint structures buried inside cosmic dust, and isolated planetary mass objects wandering alone through space without parent stars. It was a reminder that even the most familiar corners of the universe still conceal enormous unknowns. But perhaps the most breathtaking images are those revealing the cosmic web itself. On the largest scales imaginable, galaxies do not appear randomly scattered. They form interconnected strands stretching across the universe like gigantic threads of light. Enormous voids lie between them, vast regions where almost nothing exists. The result is haunting. The universe begins to resemble something organized, almost alive in structure, shaped by invisible relationships extending across incomprehensible distances. Some scientists compare it to neural networks inside the human brain. Others describe it as a kind of cosmic skeleton. Whatever comparison is used, one truth becomes unavoidable. Reality is far more structured than human intuition ever imagined. Euclid is also helping scientists investigate another terrifying mystery: dark energy. While dark matter pulls structures together through gravity, dark energy appears to do the opposite. It drives the accelerated expansion of the universe itself, pushing galaxies farther apart over time. No one fully understands what dark energy actually is. Yet it may determine the ultimate fate of the cosmos. By studying galaxy distributions and cosmic expansion across billions of years, Euclid may help reveal whether dark energy behaves consistently or changes over time. If it evolves, then some of the fundamental assumptions behind modern cosmology may need revision. There is a strange psychological effect that comes from looking too deeply into the universe. At first, discovery feels exciting. New galaxies, distant stars, beautiful cosmic structures. But eventually something changes. The scale becomes overwhelming. Patterns emerge that feel almost impossible. And slowly, the comforting idea that humanity understands the universe begins to dissolve. Euclid may be pushing science toward that point. Because the deeper its survey expands, the more the cosmos appears governed by forces we still cannot directly explain. Dark matter shapes galaxies but remains invisible. Dark energy drives expansion but cannot be identified. Entire regions of reality seem controlled by phenomena that exist beyond ordinary human perception. What we call the visible universe may actually be the smallest fraction of what is truly there. And that realization changes everything. For centuries, humans assumed that what could be seen represented most of reality. Ancient astronomers mapped stars with the naked eye. Later telescopes revealed planets, nebulae, and galaxies. Every new instrument expanded the known universe. But Euclid introduces a far stranger idea. The most important structures in existence may be fundamentally invisible. Imagine standing inside a vast city at night while only a few scattered lights remain visible. You could see fragments of roads and buildings, but the true structure holding everything together would remain hidden in darkness. That may be what humanity experiences when observing the cosmos. Stars and galaxies could simply be illuminated traces of something much larger beneath them. And Euclid is beginning to expose that hidden foundation. One of the mission's greatest strengths is its ability to look across enormous spans of cosmic time simultaneously. Nearby galaxies appear as they exist now, while distant ones appear as they existed billions of years ago when the universe was still young. In a single survey, past and present coexist together. Light from ancient epochs overlaps with modern cosmic structures, creating something almost unsettling. Space becomes a record of history itself. And within that history, scientists are noticing patterns that may challenge current cosmological timelines. Some early observations suggest galaxies may have clustered together faster than expected. Structures appear more developed in the distant universe than certain models predicted. If confirmed, this could mean the processes governing cosmic evolution were more efficient in the early universe than modern theories currently allow. That possibility carries enormous consequences. Because modern cosmology is built upon assumptions about how matter forms structure over time. If galaxies organized earlier, if dark matter shaped reality faster, or if cosmic expansion behaved differently in the past, then entire sections of theoretical physics may require revision. And then there are the voids. At first glance, cosmic voids seem empty. Vast regions where very few galaxies exist. But Euclid reveals that even emptiness contains structure. These enormous gaps are shaped by the same invisible forces guiding clusters and filaments. Scientists believe studying these voids may help uncover the true nature of dark energy itself. That is where the mystery becomes even more profound. Dark energy may not be constant. Some early analyses suggest its influence could change over time. If true, then the expansion of the universe may not follow a simple predictable path. The ultimate fate of the cosmos, endless expansion, collapse, or something stranger, could depend on forces humanity still barely understands. Think about how extraordinary that is. A telescope quietly orbiting near L2 may help determine how the universe itself will end. But Euclid is creating another challenge as well. Its datasets are almost unimaginably vast. Billions of galaxies. Countless distortions. Structures extending across incomprehensible scales. The information is becoming so enormous and interconnected that human intuition alone struggles to interpret it. Increasingly, scientists rely on artificial intelligence and machine learning to search for hidden patterns inside the data. Algorithms identify relationships too subtle or massive for direct human analysis. In a strange way, humanity is now building intelligent systems to help decode a universe too complex for the human mind to fully process alone. There is something both inspiring and unsettling about that. Machines helping humans understand the invisible structure of reality. And perhaps this is only the beginning. Because history suggests that the most revolutionary discoveries often emerge unexpectedly. Telescopes built for one purpose end up uncovering something entirely different. Euclid may eventually detect anomalies no theory predicts. Strange gravitational behavior. Unknown cosmic structures. Evidence forcing scientists to rethink the laws governing space-time itself. Not because science is collapsing, but because knowledge expands fastest where certainty ends. And maybe that is the deepest lesson hidden inside Euclid's observations. The universe is not becoming simpler as we explore it. It is becoming stranger, more layered, more difficult to comprehend. Every answer reveals deeper mysteries beneath it. Every map exposes new unknowns waiting in the darkness. The night sky once looked calm and silent. Now it feels alive with hidden architecture.